Good morning, everyone.
Good
All
morning,
right.
sir.
Yeah, good morning. All right. So let's continue with constraint motion. We'll do wedge constraints. Then we'll go for some more problems. But wedge constraints is little tricky. If you can understand what is happening there, then it becomes very simple. So let's start with wedge constraint situation. Let me look at a problem. Okay. Look at the students. I've got two blocks. All right. And if one block is moving with velocity v naught, the other, what is the velocity of the other block? Because they are in contact with each other, this is pushing this one. Velocity of this will also be v naught, right?
Yes,
So yeah. So if there is a contact between two surfaces, velocity along the normal will be same. If they are moving in contact, velocity along the normal will be same, not along the tangent. Let's say I've got a block like this. It is slipping down and it is going forward. So what is the velocity on this block forward? Velocity along this normal will be same. So its velocity will also be v naught forward and some vy downward. Vy downward you are not bothered right now. But what I'm trying to convey is if there are two surfaces in contact, then the velocities along the common normal will be same. Velocities along the common normal will be same. Alright. Okay, let's consider this case now. For a block wedge like this, making angle theta, and there's a rod, and there's a slider here. Along which this glides. Alright? This rod is gliding along the sun. So if this moves towards that, this goes up. If this goes towards that comes down. Alright? So everything is okay. This is moving towards right, the rod will come down. If this rod wedge moves towards left, rod will go up. If this wedge moves towards right, rod will come down. Agreed? Okay. Now let the wedge move towards right by x. This rod comes down by y. If this is moving towards right by x, and this rod is coming down by y by x is tan theta. So y is equal to x tan theta. If this is going at velocity v naught, dy dt, which is velocity of the rod, is equal to v naught tan theta. Understood how I got this? By measuring the displacements. Ratio of displacement is tan theta. If this wedge moves towards right, if the wedge moves towards right by x, the rod comes down by y. If I observe carefully, y by x is tan theta. So y is equal to x tan theta. dy by dt is equal to vr, which is velocity of the rod, which is equal to dx by dt to tan theta. Tan theta is a constant into dx by dt. Dx by dt is v naught given. Velocity of the right towards right is given v naught. So vr is equal to v naught tan theta. Okay. Are you able to hear
the
me,
last
students?
step. Yes, sir.
Ah.
సో లాస్ట్ స్టెప్ మళ్ళీ చెప్పారు
y is equal to x
విఆర్
tan theta వరకు ఇక్కడ వరకు అర్థమైంది కదా.
ఎస్ సార్
Now I'm differentiating on both sides with respect to time. dy by dt is equal to tan theta naught into dx by dt. dy by dt ఏంటి? vr, velocity of the rod, into v naught tan theta. Okay. I'm just differentiating on both sides
Yes,
with
sir.
respect to time. But now let us do it the other way. What is the other way? Velocity along the common normal should be same. Right? Let's get that. Get the same relation using that concept. And the idea is if this comes down by velocity of this point at contact, point of contact on this surface is v naught towards right. Velocity of this point of contact is vr downward. Right? Now if I see this, if this is theta along the normal, if this is my normal. If this is my normal, this is my 90 minus theta. This is also theta. And this is v naught, this is 90 minus theta. Look at the students. Along this normal, velocity of this rod along the normal should be equal to velocity of the wedge along the normal, common normal. I'll magnify the diagram and draw. This is the rod and this is the wedge. Wedge is going towards right with velocity v naught. This is coming down with velocity vr. And this is my common normal. If this is my common normal, this is theta. This is 90 minus theta. So Vr cos of 90 minus theta should be equal to V naught cos of 90, Vr cos theta should be equal to V naught cos of 90 minus theta. So Vr cos theta is equal to V naught sin theta. So Vr is equal to V naught tan theta. Understand this point very carefully. All I'm doing is spotting 2 points at the point of contact, one on one surface, the other on the other surface. I am taking velocities of these 2 points, drawing the velocities of these 2 points, taking the components of these 2 velocities along the common normal. When I take the velocities along the common normal, they have to be equal because these 2 points, these two are going to touch with each other. They are always in contact with each other. They're not getting separated. That means velocity along the common normal will be same. All right, is it okay? Understood?
Yes, sir.
Okay. Now I'll give you a question. I'll keep this diagram like this itself. This rod is coming down with velocity v naught. Find the velocity of the hanging block. This angle is 45 degrees. This rod is coming down with velocity v naught. All right. So what happens if this rod is coming down with v naught? If I consider this point of contact over here, one point on this rod, one point on the wedge, one point on the rod, one point on the wedge. This is coming down with v naught, I said. This angle is 45. Let this be Vx, wedge, velocity of the wedge. Vx sine theta should be equal to V naught cos theta. V naught cos theta should be equal to Vx sine theta. So Vx is equal to V naught tan theta, which is equal to V naught, because tan 45 is 1. I got Vx to be V naught. If this is V naught, this pulley comes down by V naught, spring slackens by 2 V naught, this block has to go down by
2 V0.
velocity has 2 V naught. So if the rod is coming down with V naught and this angle is 45, that block is coming down with 2 V naught. Alright? I'm sorry, I used the wrong term. If this moves towards right by x, this pulley comes down by x, string slackens by 2x, this block comes down by 2x, then velocity should differentiate, I'll get V naught and 2 V naught. Alright. Now do the same thing for this is 30 degrees. When this is 30 degrees, find the velocity of the hanging block. When the rod is coming down with velocity V naught. Students, చేస్తున్నారా?
Yes, sir.
Okay.
2 V0 by root 3, sir. 2 V0 by root
Okay. What is the velocity of the wedge?
V naught root 3, sir.
3. V0 by root.
Hold on a second. This is cot theta. See, students, that's what I make such mistakes sometimes. V naught cos by sine. So this is cot theta. And so happened that cot 45 and tan 45 is equal to 1, so that worked out. But that's cot theta, not tan theta. Now tell me the answer. It's 30 degrees. So Vx will be equal to V naught cot
Root 3.
30.
2 root 3 V0, sir.
What
2
is
root
cot
3
30?
V0.
Root 3, sir.
Cot 30 is root 3, sir.
Root 3, right. So root 3 V naught. So this will be 2 root 3 V naught, right. That's it.
Yes.
Okay, now I'll give you a little change in this one. This is 60 degrees and
Root 3 V0, sir.
it's 60 degrees now. Sorry, it's 60 degrees. I changed it.
Sir, 2 V naught by root
V0 by root 3, sir. V0 by root 3.
Mani, what is the velocity of the wedge?
2 V0 by root.
How? Cot 60, na?
V
V naught
naught
cos
3.
60. Cot
V naught
60
by
is
root.
what?
1 by root 3, sir.
1 by root.
Right. So Vx is V naught by root 3. So this is V naught by root 3. V naught by root 3. V naught by root 3 plus 0 by 2. So V naught by 2 root 3.
Yes.
Yeah, sir.
Right? So V naught by 2 root 3 is the right answer. That's what you said?
Yeah, sir.
Hmm. Now I'll give you one interesting looking problem. No, it looks good. To look at, it's good. I'll show you which one. I've got a wedge and a cylinder. This is a vertical wall. This is a horizontal surface. There's a wedge like this at an angle of 45 degrees. And I've got a cylinder like this. All right. Now, this is going towards left with velocity v naught. I have to find the velocity of the cylinder, downward velocity of the cylinder. Does it go down or go up? If this goes towards left,
Down, sir.
down. So I have to find the downward velocity of cylinder. How do I do it? Don't go by the formula. All right, formulas are misleading always. In physics, they're misleading. Let's go with logic. At this point and this point, I'll consider. This point is going towards left with v naught. This point is coming down with velocity vx. Along this normal, vx cos 45 is equal to v naught cos 45. So v naught cos 45, which is v naught by root 2, is equal to vx by root 2. Root 2 gets cancelled. Vx is equal to v naught. So because this angle is 45, this is coming on with v naught. But now let this angle be 30. Now tell me the answer. If the angle is 30, this is 30, this will also be 30, this will be 60. So v naught cos 60 is equal to vx cos 30. Right? So v naught cos 60 is v naught by 2 is equal to vx cos 30 root 3 by 2. So vx is equal to v naught by root 3. In the second case, vx is equal to v naught by root 3. And the angle is 30 degrees. All right. Have you understood this point? Students, have you understood the point? The point is this. At a point of contact, I'll take 2 points. One point on one surface, the other point on the other surface. One point on this body, one point on this body at the point of contact. Point of contact దగ్గర, I'll select 2 points. One on this side, one on this side. Between the point of contacts. I mean, either side of the point of contacts. And I'll take the velocities along the normal to be equal. So velocity component of Vx, cylinder's velocity component along the normal should be equal to wedge velocity along the component of velocity along the normal. Is it clear, students?
Sir, angles ఎలా
angles ఎలా వచ్చాయి? That's a good question. చూడండి, ఇది theta అనుకుంటే ఇది నార్మల్ ఉంది. If this is normal, this is theta, this is vertical. ఇది theta అంటే ఇది 90 minus theta. ఇది 90 minus theta అంటే మరి ఇది theta కదా. If this is theta, this again 90 minus theta. Is it okay? If this theta, this is 90 minus theta. If this is 90 minus theta, this is theta. Because it's normal to the surface. If theta ante the 90 minus theta. So one velocity is this way, one velocity is this way. Vr or Vx cos 60 is equal to V naught cos of 90 minus theta. Cos of 90 minus theta is
sin theta.
Sin theta. So I'll get V naught, Vr cos theta is equal to V naught sin theta. All right. Don't remember V is equal to V naught tan theta. Don't remember like that. Because if I give you this angle, things will vary. All right. If I give you this angle, everything will vary. If I give you this angle, things are different. Equation is different. All right. So now I get gradation, right? What am I doing basically? I'm equating the velocities component along the normal. Velocities of what? Velocities of 2 points at the point of contact. ఇక్కడ point of contact లో ఏమేమి velocities points ఉన్నాయి? ఇదొక point ఉంది, ఇదొక point ఉంది. Velocity component of this point along the normal is Vx cos 30. ఇది 30 అంటే ఇది 30. ఇది 30 అంటే ఇది 60. V naught cos 60. V naught by 2 is equal to V naught root 3x by 2. So V naught is equal to V naught by root 3. But look at the students, it is coming vertically downwards because this wall is not allowing it to move horizontally. So it is coming vertically downwards. So my velocity of sphere is minus j cap. Velocity is downward. Velocity of the wedge is towards left. All right.
Yes, sir.
Okay. Find the velocity of the block, or this velocity of the block is given as v naught. Find the velocity of the sphere. Find the velocity of the sphere. Cylinder, whatever. Cylinder ఇలా ఉంది. Wedge ఇలా ఉంది. Think about it. What's the velocity of the wedge? If this is v naught, what is the velocity of the wedge?
V naught by 2.
Good. How could you get it? Because this is 0, this is v naught. V naught plus 0 by 2 is v naught by 2. Velocity of the
Yes.
wedge. V naught by 2 వచ్చినప్పుడు, if this is v naught by 2, this is 30 degrees, it's coming vertically downwards. Why is it coming vertically downwards? Because this vertical wall is not allowing it to move horizontally. All right. So I'll take 2 points at the point of contact, point 1, point 2. Velocity of point 1 component along the normal should be equal to component of velocity of point 2 along the same normal. So v naught by 2 cos 60 is equal to v naught vx cos 30. So vx is equal to v naught by 2 root 3. All right. Now comes the interesting problem. Are you all okay with this? Is this problem okay? Students, good morning. Are you all there? Are you all awake?
Sir, can you one
Yes.
second?
Sorry?
Can you repeat once again?
Yeah, sure. This is the wedge and cylinder. Wedge is moving towards left. Why is it moving towards left? Because this block is coming downward. If the wedge moves towards left, this wall is not allowing the cylinder to move horizontally. Cylinder will move vertically downward. If this moves with velocity v naught, string velocity is v naught ikkada, e velocity is 0 only. Why? Because it's connected to the rigid support.
Contact. Yes.
Rigid support, right? So velocity of the pulley will be what? 0 plus v naught by 2 is velocity of this point. So v naught by 2 is the velocity of this point. So velocity of the wedge is v naught by 2. Agreed? Who asked me the question just now?
Yes, sir.
Yeah, who asked? What's your name?
Akshay, sir.
Akshaya. All right. So Akshaya, it is V by 2, right? V naught by 2. But now I have to find the velocity of the cylinder, which is coming downward. I'll take at point of contact 2 points. 1 point on the cylinder, 1 point on the wedge. 1 point on the cylinder has a velocity of Vx required. This point has a velocity of V naught by 2. So I take component of Vx along normal. That should be equal to component of wedge along normal. So V naught by 2 cos 60 is equal to Vx root 3 by 2 sin 30. 2 gets cancelled out. I'll have Vx is equal to V naught by 2 root 3. Alright, that's it. Is it now clear, students? Akshay, is it okay?
Okay, sir.
Okay, good that you asked. Now, next problem is a very interesting problem. Little tricky also, it will take some time for us to solve this. So, but follow this carefully. Now, instead of the wall here, I've got a movable wedge. Because of the wall, it was not moving horizontally. But because of the wedge is going towards right with 2 V naught. Required to find, okay, that is moving towards right with 2 V naught, and this is moving towards left with V naught. Required to find the velocity of the cylinder in between. Alright, required to find the velocity Vx of the cylinder. This is V naught towards left, that is 2 V naught towards right. Now look at the students. During this motion, this point is in contact with this wedge, this point is in contact with this wedge. If I consider these two bodies, I'll consider a point here. I'll consider a point here. Velocity of this is 2 V naught. Velocity of this is Vx. Alright. Horizontal velocity is Vx. Vertical velocity is Vy. Intak mundu, there was a wall because of which Vx was 0. There was only Vy. But now that wall is movable. It's a wedge. So because of which I have a horizontal velocity also of the cylinder. Let's see how. This is Vx. So Vx should be equal to 2 V naught. Alright. That means Vx is equal to 2 V naught and Vy is Vy itself. Now what do we do? What is the velocity of this point? 2 V naught Vy. I got x velocity. See, I want velocity of the sphere. Vs bar is equal to, what is the x velocity I got? 2 V naught I cap plus something j cap. Right? This something is what I have to find out now. The procedure is interesting. Alright, please follow carefully. Py cos 30 minus 2 V naught sin 30 should be equal to V naught cos 60.
Sir, can you repeat it once again?
Yes. I'll just draw it bigger. I'll draw it over here. This is one point on this surface. This is the other point on this surface. This is moving towards left with V naught. This is moving towards right with 2 V naught. And this is moving towards vertically by with velocity Vy. Now, along this common normal, I have to take components. Component of these two vectors along the normal should be equal to component of this vector along the normal. These two velocities are the velocity of this point over here. This velocity is the velocity of the wedge over here. Wedge doesn't have vertical velocity, right? It has only horizontal velocity. But whereas this cylinder, in the previous case where it was attached to the wall was stopping it from moving horizontally, so it had no horizontal velocity. But now instead of the wall, I have got wedge, which is moving with 2 V naught, which means its horizontal velocity is 2 V naught if it considers this point of contact. Now coming back to this point of contact, it will have two velocities, horizontal and vertical, this point of contact. I take the component of this along
Normal.
exactly. Thank you. So Vy and this is 30. V naught cos 30 is equal to Vy cos 60 minus, they're in opposite direction. See, this is this component that is above and this is below. This is coming down, this is going up. Minus 2V naught cos 30. So 2 gets cancelled out. Vy is equal to 3V naught root 3. Is it okay? Check the calculation now. Is the calculation fine?
Yes, sir.
Alright. So I got V naught, 3V naught root 3. So 2V naught I cap minus 3V naught root 3 J cap. Alright. Is the problem clear? Whenever you have a wedge constraint, this is called wedge constraint. That means along the normal, I consider 2 points, one on one surface, the other on the other surface. 2 points, one on each surface. I'll find the velocities of these 2 points. I'll take the component of these velocities along the normal, common normal, and I equate them. The component of velocity of this wedge along normal should be equal to component of this velocity along the normal.
Yes, sir.
All right. Now let's do one more. I've got a rigid wall. This is a wedge at an angle of 45. There's a rod like this. I have to find the vertical velocity of the rod. It's going towards right with velocity V naught. It's coming down with velocity V or Vx. I have to find the vertical velocity of the rod. So what is happening? If this goes towards right, that comes down. If this goes towards left, that goes up. Hai na?
Yes, sir.
Now, I take the 2 points of contact over here and over here. I'll magnify and draw. Point over here, point over here. Along this common normal, my velocity should be same. Component of velocity should be same. This is V naught. This is Vx. If this is 45, this is 45, this is 45. V naught cos 45 should be equal to Vx cos 45. So Vx is equal to V naught. Pretty simple. Because this angle is 45, you can just look and say. But what if the angle is 30 degrees? If this angle is 30, this angle is 30,
30.
this angle is
90 minus 30.
right 60.
60.
Correct, good. That's 60. So V naught cos 60, which is V naught by 2, should be equal to Vx cos 30. 2 gets cancelled out. Vx is equal to V naught by root 3. I didn't use Vr is equal to V naught tan theta, Vr is equal to Vr naught cot theta, all those formulae. I went to the basic logic. The logic says velocity of the points of contact along the common normal will be same. All right. Okay, now we've got 18 more minutes. Let's look at another problem. Now we'll go back to fully constrained, string constraint.
So we
Now
can't
this
see
is
the
in
line.
turn. Sorry.
Can you drop, darker? Seem to be light.
Sorry. Oh, sorry. I'll just fill in. Give me a minute. Yeah, I'll just draw it darker, but there are three blocks, A, B, and C. Given the velocity of C is V naught, I have to find the velocity of A and B. All right. I'll just draw it darker. Okay. Lines are okay. All right. So this is block A, block B, and block C. Block C is coming down to velocity V naught, which is equal to, let's say, 2 meters per second or 2 centimeters per second, whatever. It's V naught. How to find the velocities of A and B? How do I do? What is the velocity of B?
Same, sir. Equal. 2.
Correct. It's V naught. Yeah, 2. Now let this be Vx. Now, look at the students. If this moves by x, string slackens by x, and x,
4x.
4x. So this 4x slackened is tightened by movement of this block, let's say x prime. If it moves by x prime, string is tightened by x prime, and x prime, 3x prime. So this slackening should be equal to tightening. So I'll have 4Vx is equal to 3V naught. Vx is equal to 3V naught by 4. So this goes with 3V naught by 4, this goes with V naught, and this goes with V naught. All right.
So can
But
you
now
repeat
let's say,
again?
see,
3x not prime, sir.
yeah,
I don't
see,
understand.
okay. If this slackens by if this moves by x, this block moves by x, the string slackens by x, and x, 4x, right?
Yes,
So
sir.
slackening is 4x. But now let's see, if this block moves by x prime, string is tightened by x prime, and x prime, 3x prime. है ना? Look at this. X prime, X prime, and X prime. String is tightened by 3x prime. This slackening should be equal to tightening because it's remaining taut throughout the motion.
Yes, sir.
So 4x is equal to 3x prime. I differentiate. 4vx is equal to 3v naught. Vx is equal to 3v naught by 4.
Yes, sir.
But if I ask
Sir.
you what is the velocity of this point, what is the velocity of this point?
Two V naught, sir.
No, Vx ఉంది Vx. చూడండి, this velocity is 0.
2Vx, sir. 2Vx.
Yes, good. Bhavna?
Yes, sir.
Good. So this is velocity is 0 here. This velocity of this thing is 0. Velocity of this thing is, let's say, some v. V plus 0 by 2 should be equal to Vx. So V should be equal to 2Vx. Vx enta 3V naught by 4. So this will be 3V naught by 2. Towards right. Alright. Now I have to find the velocity of this point. What do I do? There are two ways of doing. I can either use this pulley or this pulley. E pulley use cheste. This is V naught. This is 3V naught by 2. This plus this by 2 is equal to V naught. Vachestundi. What do I get? 3V naught by 2 plus V prime is equal to V naught. By 2. This plus this by 2 is equal to V naught. Agreed? Find out V prime from here. Tell me what is V prime. Fast, quick. It should be quick.
Sir, minus 4
V
V
naught,
naught.
Sorry?
Minus
V
4
naught
V.
by 2, sir.
Yes, V naught by 2. 2V naught goes there. 2V naught minus 3V naught by 2. Which is how much? V naught by 2. So V prime is V naught by 2.
Yes, sir.
So V naught by 2 అంటే నాకు పాజిటివ్ వచ్చింది. That means it's going towards right with V naught by 2. అయితే ఈ పులి యూజ్ చేస్తే ఏమొస్తుంది? Vx is towards right. Velocity of this ఎంత ఉంది? V naught, because it's attached to that block. So velocity of this thing is V naught. Any point on this thing is V naught. So V naught plus V naught by 2, V naught plus V should be equal to Vx. V naught plus V prime should be equal to 2Vx. అంతే కదా? This plus this by 2 is equal to Vx. V naught plus V prime by 2 is equal to Vx. So V naught plus V prime by 2, Vx ఎంత ఉంది? 3V naught by 4. 2. So V prime 3V naught by 2 minus V naught. V naught by 2. See, I'm getting the same thing again. నేను ఈ పుల్ యూజ్ చేసిన ఆ పుల్ యూజ్ చేసిన I'm getting V naught by 2 itself. Alright. Okay, now let's find out. There's another problem. I'll just draw it and show it to you. Is the problem clear, students? అర్థమవుతుంది కదా?
Yes, sir.
How many students are there in the class? Only one. Only Bhavna is responding. But there are 12 students, 13 students are there in the class. Vignesh, do you have any problem?
No, sir.
Okay. And others, Shivani is here, Ashita is here, Gayatri is here, Omkar is here, and there are many others, but these are the names I just see. All right. So I've got a wall. This is block A, block B. I have to find velocity of point P over here, point M over here, and velocity of block A. These are the things I have to find out. So how do we find? Surely, block B's velocity is given as V naught. Okay. Let this velocity be Vx. And let this be velocity V1. Let this be V2. If V naught ante, this is 0. Velocity of this is 0. So velocity of point P, V1, V1 plus 0 by 2 is equal to V naught.
Yes, sir.
So V1 is equal to V naught. All right. Now, I have to find out velocity of block A, velocity of block point M. Let the velocity of block A be Vx. If this is Vx, this point is Vx.
Yes, sir.
If this is Vx, this point, this string is same going over here. So this will be Vx minus Vx over here.
Yes, sir.
So if I get Vx, I'm done. Now look at this, students. I'll use this pulley. I'll write pulley equation for this pulley. What do I write? This is 2v naught towards right. Vx is towards right. Vx is equal to 2v naught minus Vx by 2 is equal to Vx. So I'll have 3Vx is equal to 2v naught. Vx is equal to 2v naught by 3.
Yes, sir.
All right.
Yes, sir.
Okay. Third question is, there is another question. He wants relative velocity of point P with respect to block A. Velocity of point P with respect to block A he wants. What do I do? Velocity of P with respect to A. P is going towards right with 2
Relative
V naught.
velocity.
Relative velocity. So that is V1 minus V2, Vp minus Va. He wants Vpa. So that is Vp minus Va. Vp ఎంత ఉంది 2V naught minus
2v0.
Va. Va ఎంత ఉంది 2V naught by 3. So
2v0.
2V naught minus 2V naught by 3 ఎంత అవుతుంది? 2V naught minus 2V naught by 3.
4V naught by 3.
4v0 by
That's
3.
it. So relative velocity is 4V naught by 3. So, any doubts so far, students?
No, sir.
Because it's morning, you're not feeling like interacting, or you're feeling the class is very boring, or you are forced to attend or something. What's the reason you're not interacting today? Students, you feel the class is very boring? I mean, concept is very boring?
No, sir.
No,
No, sir.
sir.
No, sir.
Then what happened? You're not interacting. People are not interacting at all. Very silent today. Or are you people upset with something?
No, sir.
మరి ఏమైంది అందరికి? Feel free to discuss, okay? Feel free to share. సరేనా? This is the homework. This is A, this is B, this pulley is X, this pulley is Y, and this pulley is Z. Okay. And the question says, find the speed of block A when the block B is going up with 1 centimeter per second, or 1 meter per second, and the pulley Y is going up at 2 meters per second. 2 and 1. You have to find the velocity of A. Will you try this?
Yes, sir.
All you have to do is go pulley by pulley. Write an equation for this pulley, you'll get velocity of this point. Once you get velocity of this point, you'll get velocity of this point. In this pulley, if you get velocity of this one, you can get velocity of this one. Once you get velocity of these two, you can get velocity of A.
The question Malik sir explain this, sir.
Required to find velocity of A when velocity of B is given as 1 meter per second upward, and velocity of pulley Y, this middle pulley, is given 2 meters per second upward. పులి ఎక్స్ పులి జెడ్ ఇవ్వలేదు, కానీ బ్లాక్ బి ఇంకా పులి వై ఇచ్చాడు. రిక్వైర్డ్ టు ఫైండ్ వెలాసిటీ ఆఫ్ ఏ. Okay, try this for homework. Just give me a minute. I'll just inquire whether you have chemistry class or not.
Vignesh, चाट पाक में केक में से डाल रहा रे बात करना.
What's happening?
Sir, ma'am is not available. You can continue, sir.
All right, ma'am.
Just a second, sir.
Yes, ma'am.
And Navneet Kumar, if you are not interested, you can leave the session. Don't disturb others. You can continue, sir.
Thank you, ma'am. Okay. Yes, students. So how do you do this? Okay, I'll repeat the question. Someone asked me to repeat the question. See, this is arrangement. There are three pulleys X, Y, and Z, like three movable pulleys and one fixed pulley. X, Y, and Z are movable pulleys. Block A and B are attached to X and Z, Z and X, respectively. Required to find velocity of block A when velocity of block B is given as 1 meter per second upward and velocity of Y is given 2 meters per second upward. Required to find velocity of A.
Okay, sir.
Right?
Okay.
Yeah.
Yes.
Yeah. Take time, think about it. It's a good question. మంచి క్వశ్చన్స్ వదిలేయకూడదు.
Sir, is it two, sir? 2 meter per second.
టూ వచ్చిందా? Let's see.
Yes.
Okay, I'll wait for others to try. Bhavna, let's just wait for 2 minutes. Okay.
Okay, sir.
After this problem, we'll
4,
discuss
sir.
last
4.
week's. Okay, 4. One says 2, the other says 4. Okay. After this problem, we'll discuss last week's question paper. All right. There are good questions in that. I'll discuss the whole paper. Almost the whole paper. All right. Except 1 or 2 questions we may leave which are easy, but we'll discuss the whole paper. All right. That's better. Or should I go ahead with the concept? ఎలా చేస్తున్నారు ఇది? Okay, I'll not interrupt. Think and tell.
Sir, is it 1.5?
Okay, even I don't know the answer. I have to do it. I have to calculate. But once you all try, I'll go ahead. Okay, let me also do along with you. See, I got the answer. I did it orally. All right. మీరు కూడా చేయగలవాలి. చేయగలుగుతారు. See, if I'm able to do, you'll also be able to do. In fact, you'll be faster. You are younger to me. You'll be more faster than me. All right. Should I go ahead? Gayatri, you want to try? Shivani, Gayatri, Ashrita, you want to try? Shall we go ahead? Gayatri, are you there? Gayatri?
Yes, sir.
Yeah, you're able to follow Gayatri?
Yes, sir.
All right, all right. Please don't hesitate to ask anything.
Okay, sir.
Hmm. All right, shall I reveal the answer?
No, sir.
Okay, try.
Sir, I am doing.
Okay, try. Do it. లేకపోతే ఆన్సర్ చెప్పాలా మీరు ట్రై చేస్తారా సొల్యూషన్ చెప్పాను ఆన్సర్ చెప్తాను
Yes, sir.
ఆన్సర్ చెప్పాలా
Yes, sir.
ఆన్సర్
Yes,
ఇస్ జీరో
sir.
ఆన్సర్ ఇస్ జీరో రౌండ్ బిగ్ జీరో అండా శూన్య all right I'll go ahead with the solution or you want to still try I mean you still want to try
Sir, you're not visible.
Hmm. Tell you the solution students I think it's you've tried enough all right look at the solution let's do it orally if this is moving with 1 this is 0 velocity of this length is 0 any point on this is 0 velocity on this point would be something plus 0 by 2 is equal to 1
Yes,
something
sir.
so what is it something
2, sir.
2 upwards right 2 upwards if this is 2 upwards this is 2 upwards 2 plus 2 by 2
2.
2 upwards if this is 2 upwards this is 2 downwards
Yes, sir.
so 2 minus 2 by 2
0.
0 that's it pretty simple now
Yes, sir.
yeah where did you go wrong
2 + 2 చేసిన సార్ 4 వచ్చింది అందుకోసం.
ఓకే ఓకే, లాస్ట్ 2 + 2 చేశారా? ఓకే, 4/2 చేశారు, 2 వచ్చింది ఆల్రెడీ, అందుకే 2 చెప్పారు. అచ్చా, వై డిడ్ విఘ్నేష్ సే 1.5? వేర్ డిడ్ యు గో రాంగ్?
వై దగ్గర సార్, వై దగ్గర,
ఓ
వై
పులి, వై
అప్పర్.
పులి దగ్గరనా?
యా సార్,
Okay, this is
అప్పర్.
2 upward, 2 upward. You didn't take it upward or something?
నో సార్, అక్కడ నేను 2 తీసుకోకుండా 1 తీసుకున్నాను.
Okay, okay. Okay, ఇక్కడ 1 తీసుకున్నావా? Okay, okay. All right. And 4, how did you, someone got 4? Who got 4?
So Bhavna,
Okay, okay, okay. So what went wrong, Bhavna?
why place the sir?
Why పులి దగ్గర
Why
తప్పిపోయిందా?
move అయితే అవును సార్.
So why move పైకి అయితే ఈ స్ట్రింగ్ కిందకి వేస్తుంది. That you went wrong?
Yes sir.
Okay, now
No,
it's clear, right?
yes sir. Why దగ్గరనే చెప్పండి.
Okay, okay, okay. So I hope it's clear now. It's a good question.
Yes.
ఇది మంచిగా నోట్బుక్ లో రాసుకోండి. All right, let's go for the previous last week's paper. Okay. So మీరు questions చెప్తారా? Like you have the paper with you?
Yes, sir.
So if you can tell me the question, not the number, because question numbers will be shuffled. You just read some one line about the question. I mean, one line, first sentence of the question. Or else I'll send this to you. I'll send this document to you better. Have you received the PDF? Yes, you have. Okay, look at the first pick. Look at the first pick, sixth question. So what does this question say? Large number of bullets are fired in all directions with a speed of v. The maximum area on the ground on which these bullets will spread is. Or you tell me which question you want me to do, I'll do it.
సార్ నాకు
Except one
పీడిఎఫ్
question.
రాలే.
నేను 2 గ్రూప్స్ లో పంపించాను. మీరు ఏ గ్రూప్ లో ఉన్నారు?
ఏ గ్రూప్ లో లేను సార్.
Okay,
మీకు
so tell me. Sorry?
మీకు నంబర్ ఇచ్చిన సార్, మీరు యాడ్ చేయాలి.
I'm sorry. Okay, okay. ఈ రోజు యాడ్ చేస్తాను. But you tell me, okay. I cannot add your number in the group. I'm not the admin here. So I'll add Chepistanu. All right. So for now, how do we do? మీ నంబర్ చెప్తే నేను పంపిస్తాను లేకపోతే.
77.
No, you just send it in the chat box. I'll do it.
Okay, sir.
Others, please select the questions by then. 77. You send it in the chat box. Yeah. Okay.
Okay, sir.
Yeah. What's your name?
Neet.
Yeah, I send it to you, Navneet.
Okay, sir.
All right. Please select the questions so that we can solve the problems.
Sir,
Yes.
31st questions.
Okay. Look at the students. If I have got a projection with velocity v naught, range is something. All right. Sine 2 theta by g. V naught square sine 2 theta by g. But if I have angle, let's say this is theta, have angle theta 90 minus theta. Even for this, my range will be same. So when the angles are complementary, my range is same. If the angle is 30, 30 and 60, my range will be same. 15 and 75 range is same. 60 and 30 range is same. So when the angles are complementary, my range is same. Now he says, if this is H1 and this is H2, H2 minus H1 is equal to half of H1 plus H2. This is what he's saying. See, the maximum height reached by one exceeds the other by an amount equal to half the sum of the heights attained by them. Then the angle of projection for the stones is. Substitute V naught square sine square theta by 2g minus V naught square sine of 90 minus theta in t.
Cos theta.
Correct. So V naught square by 2g gets cancelled out. Sine square theta minus cos square theta is half. That is nothing but cos 2 theta is equal to half. That means 2 theta is equal to 60 degrees. Theta is equal to 30 degrees. If theta is one angle is 30, the other is complementary angle. So angles will be 30 and 60. Okay. I hope this is
Yes.
clear. The one who asked.
Yes.
Okay. All right, next question, please. All right, I'll study the question otherwise because you are taking time. Look at 37. Pick 12, 37th question. It says two particles are projected simultaneously from a point with different velocities, v1 and v2, and at different angles. The path followed by one as seen by the other. That means if I find out relative velocity of one with respect to two and relative acceleration of one with respect to two, I'll get to know the path. So relative acceleration of one with respect to two is 0. So if relative velocity, if I find out, that is the direction in which the particle seems to go. Particle 2 seems to go in that particular direction. That is velocity of 2 with respect to 1. So velocity of 2 with respect to 1 is v2 minus v1. V2 is
Next
this way.
question, sir, 78. Next
Alright.
question.
v1, v2 minus of v1. So this will be somewhere here. So particle 1 will observe 2 to go in this particular direction with constant velocity. So it will be a straight line with constant. Straight line making a constant angle with the horizontal. Alright, it makes a constant angle with the horizontal. Alright, next is 78, you said. There's a pipe through which there's a water flowing. Let the water come out with velocity v naught. Height is h naught. Horizontal distance covered is x naught. So in time of root of 2h by g, with the velocity of v naught, it's covering a distance of x naught. Everything is given except v naught. Find v naught. That's it. 2 is equal to, 3 is equal to v naught into root of 4 by g. Required to find v naught or 4 by 10. So square 9, 90 by 4. Yeah, find out v naught. That's it.
Three root 10 by 2, sir.
Yeah, that's it. 3 root 10 by 2. Right. Right. 3 root 10 by 2. If you further simplify, you get the answer. 3 root 10 by 2 is root 10 is somewhere approximately 3 point something. And 3 by 2 is 1.5 or 3.2. 3 point something माने 1.6 हो जाता है 1.6 into
4.7.
yes 4.8 or 4.7 somewhere around that. Okay, Shivani has got a question 48. Yeah, except 48. 48 is a detailed question. I would like to discuss in detail. Not now. All right, except 48, you can ask me anything. 48 is a very good question, detailed question. 48 లో ఏమవుతుందంటే in 48th question, particles are projected, no? Let's say bullets or water pellets in all directions, but with same velocity, same speed v naught. So it goes like this, goes like this. ఇలా వస్తుంది. If you look at the pattern, this whole thing is under another parabola. All these trajectories are under this umbrella, which is again a parabola with this as focus. All right, that will derive. All right, this question is given so that you skip the question. Such questions cannot be attempted in the exam. ఈ exam లో చేయలేము. All right. So you should be well prepared about the question beforehand, but you should not waste time on such questions in exam. Nine to 6. 96 is what we have done in class. Class was చేసాము, but still I'll do it again. Stone is projected from a horizontal plane, it attains maximum height h and strikes a stationary smooth wall and falls on the ground vertically below the maximum height. This goes like this, hits here, it exactly comes below this. So if this is r by 2, this is r by 4, right? And this is h. Required to find this height, h0 and h. Required to find question mark. So my range is r, maximum height is h. So my equation to the trajectory will be y is equal to x tan theta into 1 minus x by r. So when it's r by 2, sorry, when it's h0, it's r by 2 tan theta into 1 minus r by 2 by r naught. Required to find question mark at 3r by 4. 3r by 2, sorry. Tan theta 1 minus 3r by 2 by r naught. I divide these two equations. Tan theta gets cancelled out, r naught by 2 gets cancelled out, right? Then you get question mark. That's it. Okay?
3h by 4.
Yes, that's 3h by 4. Yeah, that's right. But that's easily seen in the paper pick. All right, I marked it already. 3h by 4 करके. Yeah, but 3h by 4 is right. All right, any further doubts, students? If you don't have doubts, we'll close the session here. All right, we've got 6th question. Bhavna. See, Bhavna, I've got bullets being fired in all directions. Yeah, all directions with same speed v. For what angle is the range maximum? For angle 45. For 45, range
Yes.
is maximum, right? So if it is relatively lesser angle, range is తక్కువ ఉంటుంది. 45 లో maximum ఉంటుంది. మళ్ళీ తక్కువ ఉంటుంది. అలా so range is maximum for 45. And what is that range? V naught square by G. So my area of the circle within which these bullets are fired, bullets hit the ground, is pi into V naught square by 4, V naught square by G whole square. That's it, pi r square. So area is equal to pi r square, where r is V naught square by G whole square. Why am I taking V naught square by G whole square? V naught square by G, because my radius is V naught square by G, right? Radius
Yes,
is V naught
sir.
square by G. That's it. So pi V naught power 4 by G square. All right, 12th and 8th question, just a second. Now, 12th is just a quadratic. You have to solve the quadratic, you'll get the answer. A ball is thrown with a velocity v, vertically upward with speed v, taken from point h meter above the ground. So I'll write minus h naught is equal to ut minus half gt square. So gt square minus 2v naught t minus 2h naught equal to 0. So t is equal to minus of b, which is 2v naught, plus or minus b square. I'll ignore the negative sign because I'll give you a negative time. V naught square, 4v naught square, b square minus 4ac plus 4 2h into g by 2g. So I'll write this further, v naught by g plus v naught square. If I take common, I'll get v naught by g into this goes inside now. No, this is just come inside outside. 2 goes inside. 4 by 4 is 1 plus 4 by 4 is this 2hg by v naught square. That's it. This is the answer. Or it was that's here formula minus of b plus or minus b square minus 4ac by 2a. Okay, look at the 11th question now. Is it fine? Students, is it fine?
Yes, sir.
All right. Yeah, 8th and 11th. Yeah, I'll go for 11th first, then I'll go for 8. Or I'll go for 8th first. A projectile has got a range R for two different angles. If H1 and H2 are the maximum heights reached, then. So range is maximum. Oh no, sorry. V naught square sine 2 theta by G is equal to R, which is also equal to, yeah, that's it, which is equal to R. V naught square sine square theta by 2G is equal to H1. V naught square cos square theta by 2G is equal to H2. I multiply these two. Why am I multiplying these two? Because I'll get sine square into cos square. Here I have got sine into cos. So I multiply these two and square this one. So I'll get H1, H2, V naught square by 2G into sine theta cos theta whole square. If I multiply and divide by 2, I'll get this as V naught square by G R by 8 is equal to H1 H2. Sorry, R square or R? Are you following what I'm doing? See, from here you yourself can do it. You can help me do it. See, I'm multiplying these two now. All right, these all ideas you'll get through practice.
Sir,
Yes,
can you write little big?
I'm so sorry. So V naught square by 2G whole square sine theta cos theta whole square. If I multiply and divide by 2, I'll get this. This 2 comes out, so that becomes 4 again. So V square by, this becomes R square, sorry. R square by 16 is equal to H1, H2. So R naught is equal to 4 root H1, H2. All right, just a basic algebraic manipulation, trigonometric manipulation. No physics in it. All right, just basic manipulation. Students, please go through all the examples you have done today. You have constraint motion for this week, kinematics and constraint motion. So you'll have motion, pulley and whatever, like constraints which you have done. All right, I'll go for the 11th question, then we'll stop because seems like everyone is done. I've got a tower of height H1, another tower of height H2, projectile horizontal projectile velocity V naught, it just graces this one. So minimum horizontal velocity for which the boy should throw the ball for him to just clear the obstruction B. This is x naught given. So all these things are given except v naught. So h1 minus h2 to 2h by g into v naught is equal to x naught. That's it. You have got everything except v naught. All right. That's the 11th question. Navneet, it's 11th question. I've done it.
Okay, sir.
All right, students, let's stop here. Have you got any doubts, further doubts? Doubts in
No.
constraint motion? Constraint motion అర్థమైంది కదా? So all you have to do is redo everything once. All right, redo it. ఒక్కసారి చేయండి సరిపోతుంది. It will take 15 minutes maybe. You just redo everything. Okay, this cylinder is coming down. Why is it coming down? Because there is a wall which is obstructing it from moving forward. So x component of velocity is 0. It has only y component. All right. For which constraint I'll do normal along the normal, my velocities will be same. I'll take 2 points on the surfaces, one on this surface, one on this surface. I'll equate the velocities perpendicular to the line along the common normal. All right. I'll get condition for velocity. So that like that we have done cos theta, v not tan theta, v not cot theta. Don't remember the formulae. Go with the basic concept. Angle choosకొని, angle draw చేసుకొని, then go with the concept. All right. Otherwise, you will have to lose
Okay.
your. All right. All right. All right. So let's stop here, students. And from Monday, we're going to start Newton's laws. There is small bit of general constraints remaining that will do it while doing problems in Newton's laws. Only 1 or 2 cases, but remaining all the cases we have done. Couple of cases are left, which we'll do while doing Newton's laws. But from Monday, we're going to start Newton's laws. All right. So please don't miss the class. Even if you miss 2D motion, you can follow Newton's laws provided your kinematics is okay. Kinematics okay undali, then you will be able to follow Newton's laws properly without any difficulty. All right. Chalo then, bye students, bye everyone. Have a nice day. Happy weekend. And do attempt the exam. Exam attempt చేయండి so that we can discuss the paper on Monday itself.
Okay, sir.
Okay.
Sorry? All right then. Bye everyone.
Bye, sir.
Bye.
Bye, sir.
Bye,
And
sir.
don't be upset. Okay.